Hey everybody! Today we are going to use ratios and from that using the proportions to actually solve geometric problems. This is Mr. Custodio and
Miss DeLulo.
And here we go. Alright, example 1, we have to simplify the ratios. So write the three different notations for the ratios below. Then we have to simplify the ratios. So if you look at A first, we have 67 centimeters, and that colon, when you see the colon and you're talking about ratios, you basically say 2. So this is 67 centimeters to 8 centimeters. Okay, so if we have to write down the three different notations for the ratios, well, they give us the first way, which is using the colon. So then I'm going to write down 1 as 76 centimeters to 8 centimeters. So then the thing is that we have to write all of our ratios in simplest form. So 76 and 8 can both be divided by 4. Okay, so then we should have our final answer to be, or at least the first way to write your ratio, is 19 centimeters colon 2 centimeters. So again, we read the colon as in 2. And then the second way we can write down the ratio that was given is as 19 centimeters with the word actual 2 in there, so 19 centimeters to 2 centimeters, and then finally we can write it as a fraction, 19 centimeters over 2 centimeters. Okay, so those are the three different ways that you can write down your ratio. Just make sure you always simplify or reduce each given one. So then in B, we have 4 feet over 24 feet. So they give us the third option with, where you write your ratio as a fraction. We just have to simplify it first. Okay, so we have 4 feet over 24 feet, and then they both can be divided by 4. So then our first way that we can write the ratio is 1 foot over 6 feet. Second way, 1 foot colon 6 feet, which is 1 foot to 1 foot to 6 feet. I don't know what I was doing there. And then finally, we have 1 foot, the word 2, 6 feet. Alright, a property of proportions. So the first one, we use the cross products property. And it says that in a proportion, the product of the extremes equals the product of the means, which basically we call A and D as your means and B and C as your extremes. It's just what they call the pair. And so when we use the cross products, you're actually cross multiplying the denominator and the numerator of the second fraction. So that would be considered a cross product, the denominator of the first fraction and the numerator of the second fraction. Okay, so then that should equal B times C. So that first set of cross products should equal the second set, which is A times D. Okay, so then using actual numbers, 2 over 3 equals 4 over 6. Well, if you multiply 3 and 4 together, you should get the same thing if you multiply 2 and 6 together. So 3 times 4 ends up being 12, and so does 2 times 6. There we go. So they both check out. In example 2, we actually have to solve the proportions, and notice that we have a 3/4 equal to an 8 over 16. Whenever you have two fractions equal to each other, you use the cross product property to figure out what the value of the variable is going to be. So we have the equal sign here, so we have our first set of cross products as 4 times x, so we write that out, 4x, and then equal sign, so 4x should equal the product of the second set of cross products, which is 3 times 16. So we simplify further, so we get 48 equals 4x, and then divide each side by 4, the value of our x ends up being 12. Perfect. Alright, so the second problem in this example, we have 3 over x plus 1 equals 2 over x. So this looks a little confusing because our denominator in the first fraction is x plus 1. Well, don't let that confuse you because you still use the cross product property to figure out what this proportion is or find the value of the variable is. So the first set of cross products, we have x plus 1 times 2. So we're going to write it out as 2 times the quantity of x plus 1, and then we write our equal sign because that should equal the second set of our cross products, 3 times x. Okay, so we have to deal with the 2 times the x plus 1 first. So I'm going to distribute the 2 to the x and the 1, so we get 2x plus 2 equals 3x. Okay, so now we have a two-step equation here. we can actually use a one-step equation. So we have to subtract 2x from both sides, which we are left with 2 on the left side, and then 3x minus 2x ends up just being x. So the value of our variable is just 2.
Okay, now we are going to learn about some additional properties of proportions. The first property is the reciprocal property. It says that if two ratios are equal, then their reciprocals are also equal. So let's refresh our memory what a reciprocal is. A reciprocal is when you flip the numerator and denominator of a fraction. So the reciprocal of a over b becomes b over a. So if you flip the first ratio and it becomes b over a, that is equal to also the reciprocal of the second ratio, which would be c over d, which would have to flip to equal d over c. The second property is the exchanging the means of a proportion property. So if you interchange the means of a proportion, then you form another true proportion. So what this states is that if you have a over b, which is equal to c over d, we have a proportion there. That's the same thing as if we switch the b and the c to then have a over c is equal to b over d. Now the reason why you can do this is because the cross products are still the same. Because in multiplication, order doesn't matter. So b times c is the same thing as c times b. So you can switch those cross products either, or those means either way. And the last property states that in a proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. So b is our denominator of the first ratio. We're going to add that denominator to the top. D is the denominator of the second ratio. We'll add that to the numerator as well. So then this forms an equal proportion of a plus b over b is equal to c plus d over d. Okay, let's do an example with using proportions with geometric figures. So in this diagram, JL over LH is equal to JK over KG. Find JH and JL. Now, in these problems, that original proportion tells you everything that you need to know. So that's what we're going to go off of here. Let's use the clues that it gives us. Well, I'm going to rewrite this using 4 different colors so I can relate those colors to the diagram. So JL over LH is equal to JK over KG. So let's start with identifying JL. So if I look at my diagram to the right, JL is the segment I highlighted in that dark purple. Now, there is no value attached to that segment. I see that X is the whole entire segment, and I see that 2 is the remaining little end of the segment identified by LH. But what is that little portion in between? Well, if my whole entire segment is X and the little portion on the end is 2, then that means the first part would be the whole segment, which is X, minus the end segment, which is 2. So that means that JL is equal to X minus 2. So I fill that in my first ratio. So JL over LH is 2, which is equal to JK, which is 15, over KG, which is 5. So now I've set up a proportion, and in order to solve these proportions, I'm going to use cross product. So I will multiply 5 times the quantity of X minus 2, which is equal to 15 times 2. Now don't forget that when you're multiplying by a quantity, you'll have to distribute. So 5x minus 10 is my first quantity distributed, is equal to 15 times 2, which is 30. If I add 10 to both sides, then I get 5x is equal to 40. I've run out of room, so I'll have to continue over here. 5x equals 40. I need to get x by itself, so I will divide to cancel that out to be a 1, so x equals 40 divided by 5, which is 8. Now it's easy to just circle the answer and move on, but we have to make sure that we've solved for everything that we need, which actually we need to solve for JH and JL. Now, JH, if we look back at our picture, is the whole entire segment. Now remember that whole segment is represented by x. So that means that JH is equal to 8. Now JL is represented by the first half of the segment, which we figured out is x minus 2. So that means JL is 8 minus 2, which is 6. Okay, so now from here on out, there's a couple you try nows for you guys to try on your own. And then make sure that if you don't get the answer that's marked in the packet, that you ask questions tomorrow. And then we can go over any questions that you guys have over the notes, anything that you need, okay? Thanks for tuning in.